In this video, we're going to be going over domain and range. And when we talk about domain and range, there's some terms that we have to know. One is, what is the independent variable? And when we talk about the independent variable, we're talking about the input variable of a relationship, often represented by the variable x. When we talk about the dependent variable, we're talking about the output variable of a relationship, often represented by the variable y. Now, when we talk about domain, it is the set of all possible independent variables of a relation. In other words, it's all our x values. When we talk about range, it is the set of all possible dependent variables of a relationship, or all our y values. Now, those are four things that we do have to remember as we're going through domain and range. And I want you to keep in mind that I'm using pink for the x and I'm using black for the y, so that we can kind of see as I'm creating my domain and range for my graphs. I want you to see which one is which. So let's see. Here it says, what is the difference between continuous data and discrete data? Well, when we talk about continuous data can take any value within a specific range, while discrete data can only take certain values. And let me give you an example. If I were to write the domain, let's say that this is my x-axis here, and this was my domain. Notice it has a closed dot, and then it goes all the way over. So we can write an inequality about this because it can take any value between this dot and infinity, going positive. So our lowest number is -2. So this would be -2 is less than or equal to, because it's a closed dot, x, which is less than or equal to, and since this goes on forever, on this particular graph that we've seen right here, we would say infinity. So this is an inequality, and infinity just means all real numbers, and this is my domain. Now, we don't have a range here because it doesn't show what y is, but if we had a y value, let's say we did. Let me draw another one of these. Let's say we had a y, and say it started at -1, and then we had 0 and 2 and so on. And let's say that this particular, I'm actually going to draw a circle here in pink. Let's say we had a closed dot on -1, and then it went on forever. And this is my y. So I'll change that to black. So this is my y, up and down. It starts at -1 and it goes on for infinity. Well, your range would be -1 is less than or equal to y, which is less than or equal to infinity. So this is just one example of writing an inequality for continuous data. Now, in discrete data, it's not the same. We don't write inequalities because it's not everything in between, but it's specifically just the points that are listed. And so let me give you an example of what that would look like. If we're writing discrete data, first of all, we're going to use brackets for our domain. That's going to represent my x. And in this case, we have a dot at -2, -1, 0, 1, 2, 3, and 4. And let's say it ends there. So we put our smallest number to the left. So we have -2, -1, 0, 1, 2, 3, and 4. And then we close brackets. And that is my domain right there. Now let's say, hypothetically, because this graph is really small, it's hard to see. Now I'm going to make a number line. Let's say we had a number line representing y. And let's say it started at +1. And then it went to 2, and then 3. And let's say we had 3 points on that number line. Well, if we wanted to write our range, then what we would end up having is we would end up having a bracket, and then we would just have the values 1, 2, and 3, because that's as far as it goes. So just keep in mind, that's kind of a crummy looking bracket, but keep in mind that this would be our x up here, and I should have put this in pink, but I didn't. I put it in black, and this is our range, our y values. So we're literally just be listing the values of y that are on the number line, going vertically, and just like we'd be listing the values of y going on our x-axis, which would be horizontal. So let's try this again down at the bottom and see if we can make more sense of it. Right here it says find the domain and range of the given functions and write an inequality representing its domain and range for continuous data, or write the domain and range set for discrete data, because we're going to write it two different ways. Now notice this is linear right here, and just for grins I'm going to say that this is a open dot. Let's say there's an open dot at this point, and let's say there's a closed dot at this point at origin where that line ends. This way you can see that there's going to be a difference between open dots and closed dots. For instance, whenever you have an open dot, you will use the less than or greater than symbol. Whenever you have a closed dot, you will use the less than or equal to or greater than or equal to symbol. And the reason is, when you have a closed dot, it means it actually touches that number. So it can be that number. But when you have an open dot, it means that you get close to that number, but it never actually touches it. So if we were looking at this first problem, if we're talking about domain, we're talking about our x values. Well, my open dot stops here. It starts here, and then it stops here. So that's my domain. So I'm going to write domain inside of there and put an x. So in other words, all the values from this point all the way over to this point are my domain. And we're talking about left and right because it's x values. Well, if I go right here and I count back, that's 1, 2, 3. So my domain lines up with -3. So I would go ahead and in domain I'd put -3. And since I had an open dot, I will say that it is going to be less than x. And then on this side, notice we have a closed dot. So, and that's at origin, that's at 0. So then we'll say x is less than or equal to 0. Because it can be 0 or it can be less than 0. So 0 or anything less is going to be x. But notice that x has to be greater than -3. But it can never be -3 because we have an open dot. So it can get as close as you can to -3, but never actually touch it. Now, with that being said, we talked about domain. So now we got to do our range. So in range, I'm going to do with my black pen. That's my y values. I noticed that my dot, if I go all the way across, it lines up with this point, and the highest it goes is right here. So once again, the highest it goes is 0. So I'm going to write my word in here, range, and those are going to be my y values. So my lowest value is right here. It's going to be -3, and we always put our lowest value first. So I have -3, and it is an open dot, so I'm going to put is less than y, and then I have a closed dot at 0, and so it's going to be y is less than or equal to 0. And so now I've written the domain and the range for this particular function that's been graphed. So let's look at the next one. On this next one, we have closed dots on both sides. There's a closed dot, there's a closed dot. So for my domain, I'm going to be looking from this point, which is 1, all the way to where it ends, which is this point, which is 6. And that's going to be my domain, which is my x values. So I'm going to go to say my lowest number is 1, so I'm going to say 1, and since it's a closed dot, I'm going to say is less than or equal to x, which is less than or equal to our biggest number, which is 6. Then when I go ahead and do our range, my range goes from up here all the way down here, and I'm going to write the word range. That's my y values. So my lowest y value, if you look across, is actually going to be a 2. So I'm going to say 2 is less than or equal to y, which is less than or equal to our biggest number, which will be 6. Okay, so now you know how to create an inequality based off a function that's been graphed. So let's go ahead and look at some discrete data. Notice that this is not linear, right? It doesn't have a line that connects all of it, but you do have points that move up. And I think these are actually easier because all you have to do, especially if it gives you the ordered pair, for your x values, you're just going to give the points the x values for the points. So in other words, all these numbers I underline. So for instance, I'm going to start from lowest and go to greatest. So for domain, I have 1, 2, 3, and 4. Right? 1, 2, 3, 4. And that's it. That's my domain. Notice it's already in my brackets. For my range, I'm going to look at the y values. So we have 75, 150, 225, and 300. So now I'm just going to write those in order from least to greatest. 75, 150, 225, and 300. So that is my range. So this, we simply just use our ordered pairs so that we can write all the elements of the domain and all the elements of the range. And that's all there is to it.
In this second problem here, notice that we have 3 points. We have one open dot over here on the top left. We have a closed-in dot down here at the bottom, and a closed-in dot over here on the right. So if I want to talk about domain, right, I'm going to write the word domain. That represents my values of x. And so I want to see how far does my graph go to the left and how far does it go to the right. Now if I'm going to the left, the furthest it goes to the left is this point right here at the open dot. And that value is -7. So the furthest I go left is -7. And the furthest I go to the right looks like +8. It lines up right there with +8. Now when I write this, because this is an open dot, it never actually touches -7, but it comes really close. So I'm going to go ahead and use my parenthesis because it never touches it. It's not a closed dot, but it comes really close. I'm going to type in -7, or I should say right, put my comma, and on the right side, notice it does go to a closed dot, right? That's filled in. So for that one, for +8, I'm going to go ahead and put a bracket. And that is my domain of this function. Next, I'm going to go ahead and I'm going to look at the range. So remember, when we're looking at range, we're looking at our y-axis. How far does my graph go up and how far does it go down? So I'm going to start by going down because the lower value is the one that we always put on the left. And from here, it looks like it lines up and goes down as far as -2. So this point lines up with -2. So I am going to use a bracket because that is a closed dot. So -2, comma. And then I want to see how high does my graph go. Well, the highest it goes, it looks like all the way up here, and it goes, looks like to +8 on the y-axis. Now notice that is an open dot. Because it's an open dot, I'm going to put +8, and I'm going to use the parenthesis. And that is my range. So this is all in interval notation, but that is how you find the domain and range. Now let's go ahead and say that this particular problem right here, let's say that if we were asked to do it in a different type of notation. So instead of interval notation, let's say it said set notation. So let's take a look at that, at what that would look like. So we're going to write something similar to an inequality, but we're going to start out by doing the domain. And I'm going to draw this set right here, this bracket, which represents that this is a set. And I'm going to put x because we're doing domain. Draw my line. And now I'm going to write an inequality. So when I write the inequality, right, I want to see the furthest I go left. And in this case, it is -7. And so I'm going to write -7. I am going to go ahead and put a less than symbol. The reason I'm using less than is because we have an open dot. Because there's an open dot, it never touches it, but it becomes really close. And then I'm going to put x. Now I want to look at what the furthest it goes right. Well, the furthest it goes right is +8. Notice that's a closed dot. Because it's a closed dot, I'm going to use a less than or equal to sign. And then I'm going to put 8. And then I'm going to go ahead and I'm going to close my set. And this is my domain. So it looks very similar to what you would have done in Algebra 1, right, when you're writing inequalities. The difference is we have these brackets represent that this is a set. So let's go ahead and do the range real quick. So I'm going to write range right here. Those are my y values. The lowest it goes down, we confirmed, was at -2. So I'm going to go ahead and draw my brackets. So -2. Now that is a closed dot, so therefore I'm going to use the less than or equal to sign, and I'm going to go ahead and put my y value, or my y variable I should say. And then the highest it goes all the way up to positive 8, but that is at an open dot. So I'm going to put less than positive 8. And then go ahead and close my set.
Alright, so in this lesson, notice that this is just a mini lesson, so I'm going back over a couple things. And just remember that the domain represents all the x values, so that's your movement left and right, while the range represents our y values, that's our movement up and down on the graph. So let's go ahead and just take a look at an image I'm going to draw real quick. I'm going to create a graph, and we're going to determine a few things. I also want to mention that when you think about x values, to the right of origin, it's going to be positive. To the left, it's negative. And when we talk about our y values, right, up above origin is positive, and down below is negative. Keep in mind that open dots always are going to use the less than or greater than symbol, while the closed dots are less than or equal to or greater than or equal to. This is very important so you don't put the wrong symbol and get it wrong. Now I'm going to draw some lines here so that we can go ahead and we can assign some values to this so that we can determine what the domain and what the range is. Notice that my graph, the furthest it goes to the left is that -2 value because it's 2 places left of origin. And notice going to the right, the furthest it goes to the right is +3. When I'm looking at range, I'm looking at how far it goes down and how far it goes up. So notice the highest it goes up, it lines up with that +4 right there. Notice on the x value it was 3, and on that other x value on the left side was -2, but on our y value it's -1. So keep in mind also that continuous data uses an inequality to show the domain and range. So that means that we're going to have those inequality symbols, and x will be in the middle of them and y will be in the middle of them in most instances. For instance, on this one, I'm going to go ahead and start with the domain. Notice that we go over to the left and it lines up with -2 as we stated before. So that's going to be less than because it's an open dot. Now when we go from origin and we move over to the right, notice we have a closed dot. So we're going to use that less than or equal to. And notice that it goes over 3 times. So I'm going to put 3. So really just the number on the left is your smallest value, our furthest left. And the number on the right is your greatest value, our furthest right. So from here, notice all we did is give the distance, right, that graph travels from left to right. And we made sure we put our greatest value on the right, which is the 3. And then we put our smallest value on the left. So now let's go ahead and let's do the range. We want to look at how far we go up and down on the graph. And our lowest value is going to be on the left, and our highest value is going to be on the right. Notice also I'm putting y there because we must have a y in our inequality. So the furthest it goes down is -1, and it's an open dot. So that makes a difference on my symbol. So I'm going to put -1 is less than y, because we're talking about our range, our y values. And then I'm going to go up to the highest point, which notice if I go up to the highest point, it goes up 4 times. Now that is a closed dot, so I'm going to put less than or equal to +4. And when I say closed dot, just because it was filled in. And this is my domain and range for this particular problem.